Welcome back, everybody. In this video, we're going to take a look at our next phase, and phases, I should say, of DMVPN. We're going to take a look at phase 2 and with phase 3. They're relatively close to each other in terms of operations and stuff like that. We're going to first cover what phase 2 is, and then take a look at how phase 3 operates and things like that, and then go from there. So what we were going to do is just verify that everything is working in the environment the way that it should be, and then go on from there. So without any further ado, let's go ahead and validate what's operationally handling. So we're going to go onto iOS 22, which is currently our hub, and we're going to go in here and do a show IP or a show DMVPN, and we have 3 peers up and running. We have CSR 11, iOS 24, and then iOS 25. So I'm going to do a show IP Eigrp neighbors just to verify that we have the Eigrp neighbors up and running, and I do. All of them are up and running. So what I'm also going to go do is on the other side is verify that I am learning the 172.16.101 route. And if I was to go to iOS 33 and jump out of global config and do a show IP route, we should see 172.16.101 network show up, and we do. However, you're not going to see anything from the 172.16.104 network. You're not going to see 2020 show up, anything like that. And we're going to go ahead and fix that right now with the configuration. So let's talk about what phase 2 is doing first before we dive into any more configuration breakdowns. Now, the way that this works is actually pretty straightforward. We just need to understand the logic behind it, and then we'll be in really good shape. So let's go ahead and take a look at that. Now we've covered, okay, so now I've got that resolved. I had forgot to plug my pen pad in. So right now, the way that we have it working is we go real thick and go to brown line. So right now we have GRE tunnels built from iOS 22 to these 3 nodes over the internet connectivity. Right, so we've got that running. Everything looks good. We're this route right up here, the 172.16.101 route is being learned. We haven't verified it, but like we know it's being learned down here. And if it's being learned over there, then it's a pretty good chance it's being learned in the other other 2 locations. So with that being said, it makes it easy to go ahead and verify the operations of that. So now that's phase 1, right? Phase 1 being, remember, where in order for any spoke-to-spoke communication to happen, there really isn't going to be any. It's really going to be hub to spoke and spoke to hub communication. I've dealt with plenty of customers that want this specific design because they have security policies in place. Maybe they have internet connectivity that's not local, or their internet connectivity is being delivered through a data center where their hub router is located. I've seen several different variations of the DMVPN design. So irregardless of what the main driver is, we have a operational configuration up and running. So, but we're phase 1, we're fairly limited. But now we want to expand ourselves to dive in more of the phase 2. So where we want to be able to do connectivity between the spokes like this. We want to have a full mesh, if you will, of connectivity. Well, in order for us to facilitate that, we need to move to either phase 2 or phase 3. Now, the difference between the two with this is phase 2 focuses specifically on an IGP modification. So in our case with the Eigrp, we're going to disable split horizon on the tunnel. With OSPF, you would go in and change the network type. So at the tunnel level, you would, instead of saying point to multi-point, you would transition that to broadcast. So that's one of the options that's available to you if you would like to take it that direction. With BGP, it's going to be route reflection, so on and so forth. So with that being said, we're going to go ahead and take a look at doing this. So we're going to do phase 2 first, and we're running with Eigrp because it's the industry standard. You can use any routing protocol you'd like. I prefer to use Eigrp because it's the industry standard. But one thing that I don't like to limit myself on is doing something because it's industry standard. To me, that's not always the best practice or the most appropriate way to go. I've done it with OSPF, I've done it with BGP, I've done it with Eigrp. It really depends on what the customer is looking to do. So in this case here, we're going to roll with Eigrp because it's probably what you're going to see in like a CCA lab or the most common technology or what you might see in a CCNP exam. So I'm hoping to cover that bullet point as well for those of you that are studying for the new CCNP or the new CCIEs that are coming out in early 2020. So with that being said, let's go ahead and take a look at the configuration. It's actually pretty straightforward. So that's phase 2. So we're going to focus on phase 2 for right now and then get it configured. So we're going to go ahead and bring over the config, and this is going to be a configuration that's done on the hub. So for this particular situation, if we do a show run interface tunnel 1, you're going to see that it's the same configuration we had last time. The only thing I'm going to go do is underneath interface tunnel 1, I'm going to type in no IP split horizon Eigrp 1. That's all I'm going to do. That's going to resynchronize the Eigrp tunnels and do that. So then I'm going to go jump down to iOS 33, for example, and I'm going to hit the up arrow. And we're going to see a number of additional routes showing up. We're going to see all the stuff from the remote end show up. We're going to see the Nexus routes show up. We're going to see iOS Switch 19 show up on iOS 33, so on and so forth. Now that we've done that, we can go ahead and take a look at doing a trace route to a couple of these locations. So we're going to do a trace route to 20.20.20.20, sourcing from loopback 0 numerically. We're going to do a trace, and as you can see, the first hop that you see in here is going to be, in this case here, is this is iOS 24. Then we see iOS 22. Then you see iOS 25, and then you see the destination. But if we do that trace route again, we're continuing to go through the hub, right? We're able to go directly. We're going through the hub for everything. Phase 2 is through the hub still. There is no direct to the spoke. If we went to iOS 24 and we were to do a show IP NHRP, we would see that we only have one connection set up, right? So this is cool. It allows us to get to the other spokes, but it doesn't really allow us to optimize anything, right? So is there a way to go directly to the spoke to spoke? 100% there is. So let's go ahead and talk about that for a minute and break it down, because that's going to be the next phase of our setup. So I'm going to go ahead and bust out the pen tool again. So the next step is going to be phase 3. Now phase 3 is a little bit different. We're going to keep the phase 2 implementation. So phase 2 is still in play, and you might say, what do I need phase 2 to stay? Well, you need to allow the routes from Nexus 20 to be learned over here by iOS 33. You need that route propagation still needs to happen. You need to have a route to get wherever it is you're going. So the split horizon rule still stays in play. And this is specific to Eigrp. If it was OSPF or BGP, it really wouldn't be that much of a difference, but you still need to propagate the route somehow. Now, in terms of phase 3, this is an NHRP specific configuration, where on the hub, you're going to use the redirect command, and on the spoke, you're going to use the shortcut command. And you might say, well, what's the difference between the two? Well, the shortcut is basically going to say, okay, what is the shortcut between me and my destination? So the shortcut would be a tunnel being spun up between iOS 24 and iOS 25. The redirect is going to take the NHRP resolution message that comes in from 24. It's going to send a message to 25 that's saying, hey, just so you know, there's somebody trying to talk to you. This message is going to come back to the hub, and then it's going to be sent back to the spoke. The whole communication is going to happen, go back and forth, and eventually there will be a tunnel that is spun up between them. So you'll see that same 4 hop trace route you just did a minute ago, but then you'll go from 4 hops down to 3 hops. And that third hop is going from directly spoke to spoke. And that's going to be the enhancement that we're going to go with. Once we get beyond this, then DMVPN really has hit its upper threshold of what it can do from a spoke-to-spoke communication. Then beyond that, there's additional operations like the VRF aware configuration and doing a spoke behind NAT and so on and so forth. But those will be upcoming videos. So with that being said, let's go ahead and take a look at the configuration as we're going along here and take a look at what we need to do. So the configuration again is going to be on iOS. It's going to start on the hub. And we're going to go to interface tunnel 1, type in IP NHRP and redirect. Simple as that. Then we're going to go over to 24, go to global config, interface tunnel 1, IP NHRP shortcut. We're going to take that to 25, interface tunnel 1, IP NHRP shortcut, and on CSR 11, same thing. Interface tunnel 1, IP NHRP shortcut. So there we have it. So now we do that, and now when we go back down to iOS 33 to do a trace route, and we do the trace again, we have that initial communication that goes through the hub, and then now we go directly to the spoke. Notice how I went from 4 hops down to 3 hops. If we go back to 24, we jump out of global config, give that a second, and then to do the show IP NHRP, you're going to notice an additional set of connections. You're going to see a connection that's going 220, and if we do a show IP route, Eigrp, you're going to see a % sign. The % sign is indicating next hop override. That's what this is right here. It says next hop override, and if we look specifically in the network, if we look at the 2020 right here, you're going to notice that the connection itself still points itself towards iOS 22 with 10.1.1.2. But if we look at the show IP Ceph for 20.20.20.20.20, you're going to see that the next hop actually points to 10.1.1.25, which this is telling iOS 24 send it to iOS 25 in order for it to reach its destination and go that route. Don't go via iOS 22 to get to where you got to go. And that's the beauty here. We're trying to do direct spoke-to-spoke communication and things like that. So that's basically, in a nutshell, what we're trying to accomplish here with the Phase 2 and Phase 3 configuration. So that's pretty much it. You can reference the link in the description below to see the Phase 2 and Phase 3 configurations and the actual a little bit more additional breakdowns and stuff like that. But beyond that, that's really it. There's not too much more to dive into beyond that. But with that being said, ladies and gentlemen, thank you so much for stopping by, and we'll catch you guys in the next video.